This workbook was written in Excel to help hydrologists, geologists, and water well contractors do grouting calculations quickly and accurately. Okay, so that's what this video demonstrates, and we'll start now. Okay, we're going to choose our answers to be given in bags. Our water to cement ratio, we'll choose 5.2. We're going to drill an 8-inch borehole and install 4.5-inch OD casing. There'll be 2 stages, each of which will be 200 foot in depth. The first, we're going to use neat cement. And the second stage, we're going to use 12% bentonite. Our first stage requires 40.5 bags. Our second stage requires 21.5 bags. Now these are theoretical values. Okay, we do want to find our displacement values. And the grouting method we're going to choose is pressure with inside trimming. The ID of the trimming pipe's 2 inches. The ID of the casing's 4 inches. And we're going to use 380 foot of trimming. We're going to include suction and discharge pipe or hose values. This also allows us to add 5 gallons for our pump housing. So our hoses, above ground hoses, are going to be 2 inches ID, and the suction and discharge hoses will total 50 foot in length. And we're going to say we want 3 foot of cement left in the casing after displacement. Our displacement values are as follows: just over 8 for the hoses, 62 for the 2-inch tubing, 11 for the 17 foot of casing, 5 for the pump housing, which gives us a total of just over 86 gallons. Our type of casing is 4-inch PVC Schedule 40. Our displacement fluid is going to be water, or 8.34 pounds per gallon, and our mud weight was 9.5 pounds per gallon. This gives us our P1 and P2 pressures that are shown right here below the diagram that just popped up. P1 being the pressure on the inside of the casing, P2 being the pressure at the trimming or at the discharge of your grouting machine. The factor of safety rating is given for the PVC pipe, and it shows it's equal to or above 2.1, which is good. In fact, it actually is 2.1. Next thing I want to show you is look at the pressures here and the amount of cement down here for the first stage. If I was to change this 5.2 gallons per bag of water to cement ratio to 6 gallons, you see that lowers the pressure and that lowers the bags, because that would affect it. Now, if I was to take the first stage additive, which is neat cement and weighs 15.6 pounds per gallon, and change it to 5% high-yield drilling mud, which weighs 13.4 pounds per gallon, as you can see, that weighs less, so the pressures go down, so do the number of bags. Now, answers can be given in bags, or you can choose pounds if you've got a silo or you've got a way of bringing bulk dry cement to the job site. Or you can have cubic yards if you've got a cement mixer bringing you pre-mixed cement that's showing that each stage of grouting would take 1.8 cubic yards. Next, I want to move to the cementing plan sheet. Now this is a printable sheet that shows all the information that we've added to the workbook so far. Now this could be used as a cementing plan or a cementing report. You got a place up here to put your own information in, and there's a printout button. Just if you're hooked up to a printer and hit that, it'll print out the report. Next, I want to show you the mixing information. Now here, depending on whether you're using a barrel, a box, or a tub to grout with, filling this out will give you the number of inches of water you need to put in your mixing container and the amount of additives you need to put in the container to make the mix the proper mix. So let's go with the barrel. We'll do a couple of these. And a 55-gallon barrel or drum has a diameter of 22 inches, and that's what this asks for. That's what we're going to use. 22-inch diameter, and let's say we'll mix 5 bags for that neat cement mix in each barrel. The second stage, same size barrel, we'll go with 3 bags for the 12% bentonite in each barrel. Now that brings you up this form. Here it's showing you 15.8 inches for the neat cement, 23.8 inches of water for the 12% bentonite, and it also shows you need 26 inches of bentonite, which refers to it being in a 4-inch PVC Schedule 40 pipe capped on the bottom. So if you cut a piece of 4-inch Schedule 40 pipe and made it 13 inches long, filled that up twice with the bentonite, dumped that into the water, pre-mixed it or pre-hydrated it before adding the 3 bags of cement, you would come up with your 12% bentonite. Now this also gives you all your displacement values, the total number of barrels needed for each stage of grout, and other information like the total number of gallons of water required to do all the grouting. And here's your 2 total number of bags for each stage. Okay, this is printable by hitting the close and print button, but we'll just close it and we'll go back, and this time we'll choose the rectangular tank and we'll do a 6 by 4, and we're going to use the total number of bags for the first stage, or 40.5, and 6 by 4 and 21.5 bags. So it brings up this form, which is slightly different. Now we're talking about a 6 foot long by 4 foot wide box. Here's your number of inches of water, and once again it gives you your number of inches of bentonite for your 12% mix, along with all the other information. And this, like say this, just like the last one, it's printable. Okay, next I want to move on to the pump test. Now the pump test, I've already filled out. There's a 12-foot water table. We're pumping at 500 gallons a minute. You can change the time of day you want to start the test, and you need to choose whether it's a 24, 48, or 72-hour test. Now I put in drawdown readings and recovery readings just so you can see what the graphs look like. So when I click on Give Specific Capacity, it shows that up in the upper left-hand corner here of 7.94 gallons per foot of drawdown. And there's your drawdown graph, there's your recovery graph. If you hit the printout button, it prints them both out as one sheet. And next I want to show you the well diagram. Now watch closely up here in this area right here as I add the cement for the first stage, and you can see it coming up the annulus. Now I'm going to add the water. Watch up there again. Here comes the water displacing the cement out of the trimmy, then out of the casing. And there you have it. Now we come back the next day, we tag it with trimmy, it automatically switches over to trimmy pipe. We bring that amount of cement in, and then we have to displace our above ground hoses again, which brings the cement to the surface. Now let me show you what it would look like if we were pressure grouting through the casing. Here comes our cement. There we go. Now our gallons for displacement, and I'm going to bring them in 10 at a time with this button till I get down here, and then I'll switch back over to go 1 at a time. There you have it. So we're at the first stage level. Next day, once again, tag it with the trimmy pipe, pump that amount, displace it, and it's to the surface. And then the last one is outside trimmy pipe grouting. If we were to do that with both stages, it would look like this. Here comes up the trimmy, displacing those above ground hoses and pump housing, brings it to the first stage level. Second day, tag it, bring it on up, and once again displace the hoses above the ground, and it's to the surface. Okay, that concludes my presentation. I thank you.